All right, we are live in 2518. Hi, second period. Everybody say hi, second period.
Hi, second period.
All right, so second period didn't get to go over this, so we're going to go over it for ourselves, but then they can just listen in. So be careful what you say is going to be heard by other people. Okay? So what we did is we took our data set from the zombies, and in second block they had 10 zombies on day 5, but it's the same kind of phenomenon. 2 zombies meet, they don't infect each other because they're already infected. And so our pattern starts to kind of trail off here. And so the question is, what kind of pattern is it? Let's just examine days 1 through 4 to start, because that's where the pattern is, and then we can talk about something different happening here. If you look at the best fit curve, you can see for days 1 through 4, we're doing one of these things. It starts slow at first, but then it really starts to climb. Again, when you think about slope, you've got a small slope, but then the slope is increasing, which means more and more and more zombies are being created every day. It's not like you get 2 zombies on Monday and 2 zombies on Wednesday and 2 zombies on Thursday. That would have been linear. That would have been a direct variation. This right here, anyone want to take a shot about what this is called?
Exponential.
Yes. All right. So this is an exponential relationship. And exponential relationships what we say for them is that small variations in inputs become large variations in outputs. And so that's what makes an exponential relationship different from a linear. Obviously, as days increase, the zombies increase, but it's not linear anymore. Small changes in the input lead to large changes in the output. That's what an exponential relationship does. Exponential relationships, let me write that. Y'all can write it too. And y'all can write it. Small changes in inputs cause large changes in outputs. And you can almost read that on this screen. Hope you guys can read it. Just play it back 5 times because I read it out loud. Exponential equations follow the formula. You do need to know this for the paragraph you're going to write later. Exponential equations follow the formula y equals a to the x. So whatever number of zombies we have is a constant raised to the number of days power. Okay. I believe in this case A is 2 because 1 zombie can affect 2 others. So 2 to the 0 power is 1 zombie. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3, yeah. So this is, that's, you only see that once in this example. But exponentially follows exponential is y equals a to the x power. Just as a side note now. So days 1 through 4 were exponential growth. But here's the thing about the zombies. After a while, you start to run out of fresh brains. When the whole class is zombies, there's nobody else to turn into a zombie. And so did you notice that on day 5, the pattern starts to, we're still gaining zombies here, but we're not gaining as much. So would that be more slope or less slope? Less slope. So we're kind of the steepest here for day 4. Once we hit day 5, and eventually there's going to be no more fresh brains. So the number of zombies just kind of remain a constant. So I wanted to leave some room on this graph to try to extrapolate, that's a math word. When you extrapolate a graph, you continue the pattern to see how it's going. So this right here is, this part right here is the exponential part. Doesn't it look like half a parabola? Okay. But then, what happens here is you kind of reach a natural limit just because there's not enough food to support any more zombies. We call that in environmental science a carrying capacity. We call that a carrying capacity. And so we'll see that later on in the course. That's not something that has to appear in your paragraph, but as we encounter class concepts, I want to go and point them out to you as we encounter them. But any questions on what an exponential relationship is? Just they grow in such a rate where a small change in input causes a large change in output. That's the equation they follow. If we want to talk about the equations for the other types of graphs, remember we had direct variations, which were linear, and then we had inverse variations. Now, who remembers the equation for a line? Almost. What about, where's the slope come in? Y equals mx plus b. And then if that's like if there's some kind of initial condition. Let's just leave it as a direct variation. If there's a plus b, it just means you started with something other than 0. Y equals m times x diverse? It's direct. What about inverse? There you go. That's what's up. Okay? Yeah, y equals 1 over x. I like flat fractions. Okay. So these are the three types of equations that go with the three relationships. You had the definitions yesterday. Remember direct, what happens to the outputs happens to the inputs, or other way around. What happens to the inputs also happens to the outputs. With inverse, they play opposites. So if the inputs increase, the outputs decrease. And then exponential follows that formula. Small changes in inputs cause large changes in outputs. Let's get you guys a good view of this. So when you turn in your assignment on Monday, here's what needs to come in. You've got your two graphs from yesterday, and then what I want you to do is make a sketch of this one. I'm going to bring it back. I want to go and finish for second block, and then I'll bring this back for you to make a sketch. So you're going to turn in three graphs, the two from yesterday, and you can make a sketch of this one today. Second block, hit pause and make a sketch. All right, be sure that you've got titles, labels, and scales. All right, so you're going to turn in three graphs, the two from yesterday and a sketch of this one. Then you're going to have to write a paragraph. What goes in the paragraph? I'm glad you asked. This is going to be on PBWorks, and I'll show you where that is in a minute. That right there is just kind of a refresh of the definitions I gave you. And that's on the website for you to look at as you're writing the paragraph. Doesn't that look familiar? Okay, so that's there. That's there for you to look at. Then here's what you're going to write the paragraph on. Okay, remember there's three relationships, direct, inverse, and exponential. So just give a definition of each one. Then describe the equations. Hey, if you've been paying attention in class or been watching the video, you got it. Okay? Explain what slope means. I think we've talked about that. It's the rate of change. And then the exponential curve. The number of, how does this apply to the shape of the exponential curve? When we started making zombies, did we make a lot of them at first? No. So the zombies grew slowly at first, but then by the time you get to days 4 and 5, you know, we're making four of them at a time. So the numbers increase more rapidly. So be sure to do this part of this bullet point. And as you looked at the exponential curve, doesn't it have a small slope and then a steep slope? So I'm asking you to make that connection in your writing. In the beginning, we had a flatter slope. The number of zombies was not increasing as much. But later on, with steeper slopes, that shows that many more zombies are being created. So link the idea of slope to how quickly something changes. Okay? Then, take your graph. Look at this. MPG and fuel costs. Wasn't one of the graphs from yesterday? Take a look at that graph and then tell me which of the three relationships it is. If you don't know, ask somebody. And then, one of our graphs was a direct variation, and just give the two variables, so I'm kind of checking to see if you actually understood what we said. So one of our graphs was a direct variation. Give the two variables that gave a direct variation. Again, look at your graphs, which one had the direct variation shape. Turn in 3 graphs along with the paragraph, and that's going to be folder assignment number 2. Typing is good because it's easier to read, and the easier work is to read, the better your grade usually is.
So